Hi everyone, so welcome to Mogojastro. So today, which I am going to represent, that is the third part of the organic chemistry. So in the previous class, I have already discussed about the types of organic compounds, that is the hydrocarbons as well as some other compound, so some other element, not compound, obviously compound as well as element, that is like nitrogen, hydrogen, sulfur, or CHO group, or OH group, or ROH group. All these if attached with our hydrocarbon, then what is the name of that compounds, then what is the, so depending upon that we can classify the organic compounds in the previous class. So today's class is nothing but is dedicated to the hydrocarbons only, that is there is no group associate, only types of hydrocarbons we are going to discuss. So write down the heading. Okay, so let's make a chart. So if hydrocarbon is generalized, basically generally it is divided into the two types. One is, first is aliphatic or open chain, okay, and second one is the cyclic. HC means hydrocarbon, okay, cyclic hydrocarbon. Again, aliphatic hydrocarbons are subdivided into two parts. What are they? One is saturated, another is unsaturated, okay. Now saturated hydrocarbons are nothing but the alkanes, and unsaturated hydrocarbons are subdivided into two parts. One is alkene and alkyne, okay. So these are the basic types of hydrocarbons. So hydrocarbon can be divided into aliphatic or open chain, or cyclic or closed chain. You can write it, or closed chain, okay, hydrocarbon. Now aliphatic or open chain hydrocarbon can be divided into two parts. One is saturated and another is unsaturated. And saturated hydrocarbons is nothing but the alkanes, and the unsaturated hydrocarbons are nothing but the alkene and alkyne, okay. তার মানে যদি বাংলায় বলি, তো হাইড্রোকার্বনের মূলত দুটো ভাগ, একটা হচ্ছে ওপেন চেন যেটার মধ্যে কোনো সাইক্লিক রিং থাকে না, সেটা হচ্ছে অ্যালিফ্যাটিক আর ওপেন চেন, আর একটা সাইক্লিক যেটা ওপেন চেন নয়, যেটা একটা রিং দ্বারা যুক্ত থাকে। কার্বনগুলো পরস্পরের মধ্যে সিঙ্গেল ডবল সিঙ্গেল আর ডবল ট্রিপল সিঙ্গেল আর সিঙ্গেল ডবল সিঙ্গেল ট্রিপল এরকম বন্ড দ্বারা যুক্ত থাকে। অ্যালিফ্যাটিক হাইড্রোকার্বন মানে ওপেন চেন হাইড্রোকার্বন আমার দু ধরনের হয়, একটা স্যাচুরেটেড, একটা হচ্ছে আনস্যাচুরেটেড। স্যাচুরেটেড হাইড্রোকার্বন যেটা, সেটা হচ্ছে অ্যালকেনস, মানে কি তার মানে বুঝতে পারছো, স্যাচুরেটেড হাইড্রোকার্বন কারা, which has only single bond. অ্যালকেন মানে আমরা জানি যাদের মধ্যে যেসব কম্পাউন্ডের মধ্যে কার্বন কম্পাউন্ড পরস্পরের সঙ্গে বা হাইড্রোজেনের সঙ্গে, আমি কিন্তু এখানে শুধু মাত্র হাইড্রোকার্বনের কথা বলছি, অর্থাৎ এখানে এর সঙ্গে কিন্তু কোনো গ্রুপ অ্যাসোসিয়েট থাকবে না, শুধু হাইড্রোজেন আর কার্বনের কথাই বলবো, okay. We are only dealing with the hydrogen and carbon and their bonds, that is the covalent bond. So here in a saturated hydrocarbon only single bond is present, that is the carbon hydrogen or carbon or hydrogen carbon are bonded together by obviously a covalent bond, and the nature of the bond is single bond, মানে কার্বন হাইড্রোজেন তারা পরস্পরের সঙ্গে সিঙ্গেল বন্ড দ্বারা কোভ্যালেন্ট বন্ড দ্বারা যুক্ত থাকবে। আর আনস্যাচুরেটেডে তারা কার্বন হাইড্রোজেন they are bonded maybe with double bond, single bond, or single double bond, or single triple bond, or triple double bond like this, okay. কখনো কিন্তু এটা মনে রাখবে, কখনো একটা ট্রিপল বন্ড একটা ডাবল বন্ড কখনো পাশাপাশি থাকবে না, তাহলে কিন্তু কার্বনের রাইট সাইড ও লেফট সাইডে কখনো ট্রিপল বন্ড আর ডবল বন্ড একসঙ্গে থাকতে পারে না, কারণ কার্বনের ভ্যালেন্সি 4, অ্যান্ড যদি একদিকে ট্রিপল বন্ড মানে এইটা ধর একটা কার্বন যদি হয়, এর একদিকে ট্রিপল বন্ড একদিকে ডবল বন্ড কখনো থাকতে পারে না, কারণ কি, কারণ দ্য ভ্যালেন্সি অফ কার্বন ইজ 4, সো ইট হ্যাজ অনলি 4 valence shell. So here if we consider this structure, then it is going to be wrong, because here 1 2 3 4 5 valencies are showing, but it is not possible for carbon to show its valency like 5. Okay, so that's why it cannot be drawn. Okay, so unsaturated hydrocarbons are alkene or alkyne, that is, it is nothing but single double bond, and it is nothing but that triple bond hydrocarbon. Okay, these are nothing but the unsaturated or saturated, unsaturated, and that is the alkene or alkyne. Now what is the cyclic or closed chain? So if we consider closed chain hydrocarbon, so one thing you have to remember, that for closed chain hydrocarbon we must need at least 3 carbons, because we know that if you want to cover a area, then we need at least 3 straight line. So here the same thing is there, that is, if we want to close a area, then it must be 3 carbons are there. If the structure is like this, then it can be treated as it is a closed chain hydrocarbon, and as the valence of carbon is 4, so here we can put 2H. Okay, then it only can satisfy. Okay, this is what, so this is the structural formula of this is CH2 single bond CH2 single bond CH2 and single bond. Okay, so this is what, chloropropane, sorry, not chloro, cyclopropane. Why propane? Cyclo, because this is a cyclic chain, closed chain. And why there is propane? Prop means because 1 2 3 3 carbons are present, as 3 carbon are present, so pro is there, prop is there. And now why N? Because they are all together joined by a single bond, that's why it is called propane. Now if we take one example which has a double bond associated with it, so it is CH2, it is CH2, it is CH2, CH2, CH. Here you can consider 1 2 3 4, 1 2 3 4, here 2 3 4, here 2 3 4, here 2 3 4, here 2 3 4, so all are satisfied. What is the name of it? You can name it as 1 2 3 4 5 6 carbons are present. Okay, so it can be named as cyclohexene. Why hexene? Hex because there are 6 carbon are present. Why cyclo? Because it is a cyclic chain. Why in? Because there is only one double bond is present over there, that's why it is called a cyclohexene. Okay, like this we can give an example associated with a triple bond, that is the C, then CH2, here CH2, here CH2, here CH2, like this. Okay, here how many carbons are there? 1 2 3 4 5 6 carbon are there, so it is also a cyclo. Why cyclo? Because it is a cyclic chain. Cyclo, 6 carbon, hex, triple bond is there, cyclohexane. Cyclohexane is the name of this compound. So these are nothing but the closed chain of the cyclic hydrocarbon. Okay, so these are the basic types of the hydrocarbons. Now we are going to discuss about, okay, one thing we have to know, that benzene is a very important structural formula. The structural formula of benzene is like this: two double bonds and three double bonds and 3 single bonds are present over there. Okay, so here the structure of benzene is CH, 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 CH and CH is the structural formula. If you draw this structure, now you can draw like CH, C, 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 C. Now H, 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 H and H. Now you see that here there is not there, the structure is not satisfying the valency of the carbon, because here three valencies are there. So if you put one double bond over there, then you see that 1 2 3 4 satisfied, 1 2 3 4 satisfied, 1 2 3 4 satisfied. Like this, all carbon have satisfied their valencies. Now you can draw this double bond here also, okay. So basically the thing is, the carbon, this type of hydrocarbon, closed hydrocarbon, have the double bond and single bond together, but they are in the alternate position. It means if here is the double bond, then in the next here is a single bond, again here is in the next, here is the double bond, here again next single bond, next double bond, next single bond, like this. So these bonds, these double bonds can rotate, can shift from here to here also. It is also shift from here to here also. It is from shift from here to here also. In class 11, you know, this property is known as the resonance, or due to the resonating structure of the cyclic hydrocarbon, they due to the closed chain hydrocarbons shows the resonating property, and it is very high resonating property they can show. That's why benzene has, obviously, as it is a closed hydrocarbon, so it has also a resonating structure. Then that's why this double bond can be alternate their position. It means that here this double bond can be shifted over this. If this double bond is shifted over this, again this double bond is also shifted over this, and again this double bond also shifted over this. So this makes a benzene. So the general structure of the benzene, you can write it as like this, or like this, or due to their resonating structure we can show like this. Okay, now some basic okay, if this type of rings can associate with any other groups, then it has a property called the aromaticity. Aromaticity means it shows some smell, it gives some smell. Naphthalene, phenyl, toluene, these are the very common aromatic compound which we use in our daily life. So what is the structure of the toluene? The structure of the toluene is a benzene ring. You can draw a benzene ring like this. Okay, now you can add one CH3 over here, then it is called as a toluene. Okay, the structural formula of phenol, that is the phenyl. If you put one OH over here, then it is nothing but the phenyl. What is the structure of the naphthalene? So two benzene ring can associate together to make a naphthalene. This is a common bond, so this is a naphthalene. Okay, so this is the all about the basic of hydrocarbons. There is the aliphatic or open chain, closed chain of the cyclic. Then aliphatic is divided into two parts, saturated and unsaturated. And unsaturated is the hydrocarbons which has only single bond in carbon-carbon or carbon-hydrogen. What are the unsaturated? They are subdivided into two parts. One is alkene and another is alkyne. So why they are subdivided? Depending upon the single, double bond or triple bond present in the hydrocarbons, they can be subdivided into two parts. When the double bond is present in a hydrocarbon, they are called the alkene. when the triple bond is present in hydrocarbon, they are called the alkyne. Okay, and the cyclic hydrocarbons are like this. They have the single bond, double bond or triple bond in their cyclic structure. They are a closed structure, and the very basic closed cyclic or closed chain hydrocarbon is the propane, cyclopropane. Why it is propane? Because we know that to cover area we need at least three sides, that is at least three straight lines. If we cover that straight line, so this is like the structure will be like this. So at least 3 carbon we have to need, and as they are a closed chain, that's why it is called cyclo. So cyclo is present, then prop N, single bond for N, 3 carbon for prop, and cyclofluoro, they are closed chain. So this is up to the types of hydrocarbon. Now we are going to discuss about some alkyl group. So when a group can be called as an alkyl group, I have already told in the second class that if alkane lose one hydrogen, then it becomes alkyl. Okay, so what is the general structure of the alkane? The general structure of alkane is CnH2n plus 2. What is the very basic alkane? The simplest alkane. So the simplest alkane, the simplicity or complexity is depend upon the number of carbon present. If the number of carbon present more, then it becomes a complex alkane. If the number of carbon is less, so it becomes a simple alkane. So if you consider that thing, then you can put what is N here. N is the number of carbon present. So if N is equal to 1, then if we put CnH2n plus 2, then it is becomes C1H2 into 1 plus 2, that is CH4. So very basic hydrocarbon is CH4, that is the methane. Okay, so methane become methyl, alkane become alkyl if it loses one hydrogen. So methane become methyl if loses one hydrogen. So if methane has 4 hydrogen, so obviously methyl has 3 hydrogen. So if CH4 lose one hydrogen, it becomes CH3. Is it the structure of the alkyl? It is not the complete structure of the alkyl, because carbon has 4 valencies. Here only 3 hydrogen is there. So C become the structure which I write over here is like this, but the valency of carbon is 4. So we have to need one bond. This is a vacant bond. There we can attach or we can put any other groups. So the exact structure of the alkyl is one bond and then one vacant bond, then CH3. So alkane become alkyl if it loses one hydrogen from it. So what is if the general formula of the alkane is this, then what is the general formula of alkyl? So it loses one hydrogen, it becomes CnH2n plus 1. Okay, now you put CO as N as 1, it become CH3. If you put CH2, it has become C2H5. So it is what? We have to put one bond before it. It is what? Methyl. It is ethyl. Like this you can write, puts 1 N as 1, 2, 3, 4, 5, 6 like this, and depending upon that methyl, ethyl, propyl, butyl, pentyl, hexyl, septyl, octyl, nonyl, decyl, like this. Okay, so this is the, if alkane loses one hydrogen, then it becomes alkyl. Okay, now what is the structure of the methyl now? So structure of the methyl is one bond C H H H, Okay, that is the CH3. The structure bond formula is CH3. What is ethyl? It is C2H5. So what is the structure of C2H5? So if this is the structural formula, if you abbreviate it, if you break it, it becomes CH2CH3 like this, or CH3CH2 like this. Okay, so if you write CH2 over here and CH3 over here, then it becomes more easier to put one group over this ethyl. So it becomes C C H H H H H, one bond. So this is what? CH2, CH2. This is what? CH3. And here the valency of carbon is 4. 1, 2, 3, 4. This carbon satisfy valency. Valence electron 4 valencies. But here the carbon 1, 2, 3 satisfy only 3 valencies. So we have to put one bond before it. It is waiting for some other group can attach with it. Okay. So what is propyl? It is C3. If n is equal to 3, then it become CnH2n plus 1 C3H 2 into 3 plus 1, that is a C3H7. So C3H7, what is so if you abbreviate it, it becomes CH2 CH2 CH3. Okay, so what is the structure formula of it? C 3 H's are there, here 2H, here 2H, and obviously we put one single bond before it. So this is CH2, this is CH2, this is CH3. So this is the basic hydrocarbons, that is the basic alkyl group, as CH3 is present at last. CH3, CH3, CH3. You can like this, you can break butyl. Okay, butyl is C4H. If it is 4 to the 8 plus 1, 9, C4H9. So it becomes CH2 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 CH3, 3 to 5 to 7 to 9, carbon 4, 1, 2, 3, 4 satisfied. So the structure becomes C H H H, and obviously put one vacant bond to make it that some other group can be associated with it. So this is CH3, CH2, CH2, CH2 and bond. Okay, so these are the basic alkyl group. Now we can show how some other group can be attached in that vacant bond. Okay, so now we are going to discuss about some common functional group which is attached with the alkyl group. So again, alkyl group is what? Is equal to represented R by R. Here this R is nothing but the alkyl group. What is the structural formula? It is CnH2n plus 1. Why it is 1? Because I have already told you that if one hydrogen CnH2n plus 2, that is the alkane, if loses one hydrogen, then it becomes CnH2n plus 1. Okay, this is the general formula of the structure of the alkyl group. So then alkane become alkyl. What is the property of alkane? Alkane is nothing but the single bond hydrocarbons. Okay, now some common functional group which is attached with the alkyl. Then what should be the types of the organic compound? What should be the general formula of it? What should be the suffixes we use when we write their name, and what is some, and we have to discuss some example. Okay, so I have already prepared this chart because it will take some more time if I draw this in front of you. So first we are going to discuss about the halide group. Halide means There is the X. This X, this is nothing but that. I have already told you that CH4 loses one hydrogen, it becomes CH3, but this is not the alkyl. If we put one bond before the CH3, that single covalent bond, then it becomes a alkyl group. Okay, so this is the alkyl group. R is it may be CH3, it may be C2H5, it may be C3H8 like this. Okay, so C3H7 like this. So if X is nothing but the halide. Halide means the chlorine, fluorine, bromine, iodine. Okay, that is the halogens. If halogen is associated with the alkyl, then it is called the haloalkane. Haloalkane. So the types of organic compounds is called the haloalkane. So what is the need of this functional group? The need of this functional group is to, if some functional group is attached, then we can categorize the hydrocarbon. What kind of hydrocarbons? Here, if you consider this, then we can say that we can categorize the alkyl group depending upon the functional group present with it. So this X, this OH, this HCO, this one is nothing but all of the functional group present over here. Then depending upon the structure and their compounds, it may be an element, it may be a compounds. As halide, if you consider halide, X is nothing but a chlorine, fluorine, bromine, iodine. It is nothing but an element. So if chlorine, fluorine, bromine, iodine, these types of halogen gases are associated with this alkyl group, then it becomes haloalkane. The types of the compound become haloalkane compound means the types of hydrocarbon become haloalkane. The suffix we use is nothing but the N, A-N-E, haloalkane. These last three word haloalkane, A-N-E is used. When we use this suffix, when we write the IUPAC name. Okay, in the next video I will discuss what is this IUPAC and what is the need of this IUPAC and how the IUPAC name is written, what is the need of the suffix, and obviously there is another term, what is that is a prefix, what is the prefix, and there is another also term that is called the root word. What is the root word, how we can determine the root word, and how we can determine the suffixes and prefixes. So for haloalkane, when we write the names of haloalkanes, then we have to write N at the suffix. Suffix means the at last. Okay, so two example is CH3Cl. So this CH3 is nothing but a alkyl. This is what methyl. Methane loses one hydrogen, it becomes methyl. Here it is C2H5. What is the formula of ethane? C2H6. It loses one hydrogen, it becomes C2H5. So it is, if it is ethane, then it is ethyl. N will be YL. N AN minus H, it becomes YL, ethyl, propyl, butyl, like this. So this is not the common name is methyl chloride. It has an IUPAC name, that is the chloromethane, CHLOROMETHANE. The name of the IUPAC name is chloroethane. Okay, if it is Bria, then it may be bromomethane, like this. Okay, now second group is hydrocarbon, hydroxyl. Okay, hydroxyl, hydrogen and oxygen, it has a bond before it has a bond that is associated with that R. So R has a space to take another element or compound. Previous one is nothing but an element, now it is a compound OH, that's why it is a hydroxyl. Okay, so if OH is associated with a alkyl group, it becomes alcohol. You know the alcohol, that is the sharab. Okay, alcohol. Okay, so alcohol is OL, the suffix. If we write the name of the alcohol, that is called we have to write the suffix as OL. Like CH3OH, here it is also alkyl group, methyl. This is O is the alcohol, methyl alcohol is the common name. Here C2H5OH, C2H5 is ethyl. When OH is associated with it, it becomes alcohol. So ethane will be ethyl, C2H6, minus hydrogen, it becomes C2H5, then plus associate one hydroxyl functional group, it becomes C2H5OH, that is nothing but the ethyl alcohol. Methane become methyl, and if OH hydroxyl is added with it, then it becomes alcohol. Okay, then aldehyde, that is a CHO, that is a CHO. This is the structure of the aldehyde, CHO. Here OH is not like this, it is not like not associate together, not they are become together. Here oxygen has two valencies, so C use two valencies with oxygen, and one with hydrogen and another with the R. R is nothing but the, here is nothing but, R is nothing but the alkyl group. So when CHO is present with any alkyl group, then it becomes aldehyde. Okay, the suffix we use when you write the IUPAC name, it is Al, AL. L is the first two letter of these types of the organic compound, that is the aldehyde. Like HCHO, the common name of this HCHO is formaldehyde. Okay, formaldehyde. Okay. Now CH3CHO, what is the common name of this? It is acetaldehyde. Like this we can write the IUPAC name also. We have to discuss in the next class what is the IUPAC name of formaldehyde, what is the IUPAC name of the acetaldehyde. Okay, okay. This is what? This is methanol. The IUPAC name of this is methanol. This is ethanol. Not all, Al, ALL. This is aldehyde, ethanol. If OH is there, then it is methanol, methyl alcohol or methanol, ethyl alcohol or ethanol, like this. These two are nothing but the methanol or ethanol are nothing but the methanol or ethanol is nothing but the IUPAC name. Okay. Then carboxyl, COOH. COOH means here C is two valency of C is associated with one oxygen, another oxygen and another hydrogen. This is the COOH. The structure of COOH is the carboxyl group is like this. Okay, so this is a carboxylic acid. Okay, so what is the suffix we use? Oic, O and IC, oic acid. Oic acid is the suffix. When you use the IUPAC name, write the IUPAC name, it becomes oic acid. Okay, like CH3COOH, the acetic acid. There is the carboxylic acid, acetic acid. C2H5 is the propanoic acid. The IUPAC name of propanoic acid is propanoic acid. The IUPAC name of this C2H5COOH is propanoic acid. This is CH3, then COOH. Here 2C is present, so it is ethanoic acid. The IUPAC name is ethanoic acid. Okay. Now ketone group, keto, C double bond and two spaces are there, two bonds, covalent bonds are there. There we have to write two alkyl group, one become methyl, one become another become ethyl, or two both are become methyl, or two are become ethyl, like this. So the type of compound is ketones. Okay, the suffix we use on, not one, on. If you write its IUPAC name, it means when C double bond O and two covalent bonds are there, then we have to use on if we write its IUPAC name. Okay, like CH3COCH3. Here two covalent bonds are there, which is vacant. Okay, so we can put one CH3 and another CH3 in these two sides, so it becomes CH3COCH3, or it becoms CH3COC2H5, it becomes C2H5COC2H5, like this. Okay, so CH3COCH3 is nothing but the acetone, and C2H5COC2H5 become diethyl ketone. So this is acetone, this is diethyl ketone. Now what is the name of this? It is here 1, 2, 3 carbons are present, so it is propanone, PROPANONE. One is used, is out as IUPAC name. Here it is 2C, 3C to 5C, pentanone. Why pentanone? 5C is present. If number of C is 5, then it becomes penta. Okay, now ethers, OC, that is O, and the both side of the O there is two methyl group, alkyl group we can put, that is it become ethyl, it become ethyl, it become propyl, it become pentyl, butyl, like this. Okay, so ethers is oxy. Okay, here the suffix is oxy. It means then when we write the your IUPAC name, we have to use oxy in the suffix. Okay, that like CH3 or CH3, that is the dimethyl ether. This is dimethyl ether. Okay, this is dimethyl ether or methoxymethane. It's IUPAC name. Okay, methoxymethane and oxygen become methoxy, and methane is associated with it, so it becomes methoxymethane. Here methoxy is associated with the ethane, so methoxyethane is its IUPAC name. Okay, oxy is the suffix we use. Okay, so these are the functional group. When a alkane loses one hydrogen, it become alkyl group. When that alkyl group is associated with any element or any compound, that element or compound become we can call it as a functional group. There are so many functional groups: halide, hydroxyl, aldehyde, carboxyl, keto, and the ethers. So I have briefly discussed all this. What is the structure of these functional groups, what are the types of the organic, what kind of organic compound they are, what is the suffix when we use when they are present in any alkyl group, and for that if we want to write their name in IUPAC standard, then what should be the suffix we use, what should be the prefix we use, and what should be the root word we use. That will be discussed in the next class when we are discussing about the nomenclature or the IUPAC. Okay, so there is some example of these functional groups. Hope you study well. So see you in the next class. In the next class we will discuss about the IUPAC name, and the little bit some rest basics things are there. We have to discuss that thing, and as well as we have to discuss start the IUPAC name. Okay, তো ততদিন পর্যন্ত আজকে এই পর্যন্ত থাক, পরে দেখা হচ্ছে পরে ভিডিওতে। টাটা, বাই বাই।